Okay. How are you guys? Yes? You okay? It's week 7. I know you're exhausted. I know you are.
They're on a caffeinated coffee down below, so we're going to see.
It's okay. They're out of caffeinated coffee.
They don't have decaf. It's like beer without alcohol. It just doesn't do that.
It's like a room without air. It's like beer without alcohol. So administrative, let's just chit chat. I saw my grader that does your guys' stuff come in last night. I left here around 2:30, 3 o'clock yesterday. I saw her come in, grab papers. She said she'd see me in a little bit. I'm like, sweet. I haven't gotten it back yet. I was hopefully to have a whole bunch of stuff to get back to you guys today. I didn't get it back. I don't know if maybe I misunderstood what see you later meant. But I will have stuff back to you definitely by Thursday. It's probably on my desk right now. I'm guessing that whenever I see her, Amber usually turns stuff in like almost immediately. Probably sitting on my desk waiting for you guys. I did have my other grader. She got locked out of the building yesterday. That could be what had happened too with Amber. She could have gotten locked out. Apparently the buildings were locked out like it was a normal holiday. That usually doesn't happen. Usually when we have a goofy day like Veterans Day, where there's not a goofy day, but a goofy holiday like Veterans Day, the buildings are open. But it wasn't yesterday, so there's a possibility that she got locked out. I apologize for not having stuff to get back to you today. So when Harrison asked the question, did my group turn in the quiz from last night? Possibly. It might still be in the folder, but I can't look at it yet. As soon as I get that stuff back from both my graders, I want to put progress reports out to you guys like I do each Monday or Tuesday. So you'll be getting a progress report from me, hopefully today, latest tomorrow, with how you're doing in the class on it. Like you did last week. What's the matter, Jane? You just look upset.
Our test is like a project, I feel like
It's not! Sweet Jesus, the projects are standalones. The projects are standalones. They're their own animals. Here's what that project did, just so you know. The first 2 projects, no, I lied to you. All 4 projects, all 4 of those projects, what they do is, they take sections that I think stat textbooks do too much of in too much of a mathy way. They distill them down to a more statistical way, and I spread them over 10 weeks of the term, and keep them off of your exams. Those are their own tests. That's why they add up to an exam. You'll never see that mathematics on an in-class or out-of-class assessment. They're their own tests. I mean, I try to break up the class to have as many different kinds of assessments as possible. And please never think that you're going to see project material on an in-class exam especially. I know what you guys are worried about. You're like, I'm going to walk in here on Thursdays and ask me to what's the chance 6 people have Hep C. No! Hell no! We're going to start looking at the binomial distribution today. But that is by no means indicative of what's on your exam on Thursday. Yeah, no, not at all. So don't worry about that right now, please. So, speaking of that though, I posted your out-of-class section of your next exam it's due next week. I think it's the week from today. It's got an Excel sheet component to it as well. The Excel sheet component isn't as slick as I hoped. I thought it would be a little bit slicker. It's not. I didn't get a chance to edit as much as I would have liked. But the big idea of the Excel sheet is you're doing some exploration, some deeper looks at stuff we've already started talking about in class. So that's the out-of-class part though. Keep the in-class stuff much more superficial, much more kind of nuts and bolts, very simple calculations, quick calculations, things like that. On the out-of-class, for example, I give you a data set. It's kind of an arbitrary one. I checked all your guys' last names and calculated how long they all were and put them into a distribution. And I asked you to find out if any of you have unusually long or short last names based on the rest of the classes. And the idea was, I didn't tell you which method to use. I say, you tell me which method you're going to use, you tell me why. You give me this graph, and you justify your answer with those graphs. I would never ask that in class. Not enough time. Not enough time. But, well, I take that back. There's plenty of time in class, but it would freak you out because the questions are too open-ended. That's what the truth is. It would freak you out because the questions are too open-ended. But I like open-ended questions because it forces you guys to come up with your own conclusions on things. So that's what you're going to see in the out-of-class part. The in-class part will keep it very, very close to the vest. Very, very simple. Fair enough? Do you feel a little better, Jamie? Just a smidge better. Good. I don't want you guys being upset. I want you coming in here happily accepting what's coming at you. So, speaking of which, anything from Outliers, the exam's going to cover these sections. Let me grab a marker real quick. Your exam's going to be from 3 sections. You've got relative position, which I think we've happily knocked out. You've got outliers, and you've got probability distributions. And the last 3 weeks or 4 weeks we have together will be the next 3 and the last 3 topics. If you look at your homework sheet, it's essentially 9 topics. And I've tried very hard, that's why you have your projects, to distill it down to there's only 9 things on that list. The idea of those projects is just a big buckshot of probability. And it's my attempt at a nod to realize that you can't really learn these things in isolation. Some must be learned kind of parallel or at the same time. Which is why I like kind of offloading them to those projects where you have as much time as you want essentially to work on things. So please, rest your mind, my friend. Rest your mind. So, this is Thursday. Anything, I know we've already discussed this section, anything from these two give you guys agita? Please, Robert, thank you.
Yeah, I got a question about this problem here that they did with the women where the children wake them up.
Let's look, huh?
Yeah, well, they said something here. It says the women would be expected to be awakened during the evening on average 2.1 times.
2.1 times.
But then they go, the number 1.1 is the long-term average or expected value. Is that a typo? Or?
I don't know. Let's take a look.
Okay.
This doesn't ring a bell to me. Which I'm guessing it means this is one of the ones that had a solution.
Yeah, I think so.
And I'm only making videos so. Let's call this. And is this in the outliers, my friend? Or is this in the probability?
It's in the probability.
Okay, let's grab that then. Let's do this. Let's do this.
Oh, actually, it's in the notes. It's an example from the notes.
Oh, in the actual text of the
Yeah, in the
text,
text,
if
yeah.
you will. Gotcha. Back over here. We need to go to. Do you know what page it is?
No.
Okay, that's all right.
So it's
That's all right, don't worry about it. I can look it up.
It's in between 159 and 164.
Thank you, Addie. Somewhere in here.
Like a-
Question, true, false quiz. Child psychologist? Boom! Here we go, here we go, here we go.
Yeah, that's it.
Child psychologist is interested in the number of times a newborn baby's crying. You guys say that again? Make it bigger.
I have a father just sleeps through it.
Yeah.
Some fathers do. Some don't. Some have, I have wonderful memories of sitting with Max in front of the fireplace at like 3 a.m. Like him waking up and feeding and passing out on my chest. I read somewhere that babies love that because it reminds them of being in the womb. So I would just turn the fireplace on. Thank God for gas-fired fireplaces. I don't go outside and get wood. Just sleeping there until Max fell back asleep, and carrying a bag of potatoes, put the crib, and riding my bike to work at 3:30.
Nice.
Now I'm awake now. Okay, from a random sample of 50 mothers, the following information was obtained. Let X equal the number of times a newborn wakes its mother after midnight. Oh my God, 5. That actually happened. It happened once, 1 in 50. Okay, so what we got right here, of those 50, we're treating this as a population representation sample. So you've got, how many mothers were not wakened at all after midnight? 2 out of 50 in the sample. 2 out of 50 were not wakened at all. So we're going to call that, what, 4%? 11 of the 50 mothers, or 22% of the mothers, were woken once after midnight. 46% twice, 18% thrice, 8% 4 times, and then the last 2% was 5 times. And that should sum up to 100% because it's on a fraction, so we're happy there. Good so far. So Robert, the question you have is down here. It's discrete PDF because, yep. That's what we just talked about. Oh, now we're done. Where'd the average come from?
You might be on the solution there where it says page 2.
Oh, maybe! Maybe that's where I am.
Yeah, because I'm trying to look at this and go, what?
Okay, so I gotta go back. Wait, but I'm in the chapter. 207, is that where it is, Skyler?
Yeah.
Hang on.
217.
217. I heard 207.
You typed in 217.
But I'm on page 207. I have to go 10 pages ahead because of the way it's indexed. I'm so confused right now. I don't know where I should be in the book. So is it finding the average of that distribution? Like on average, how many times are they awakened?
Well, on average, I mean, it did, and I came up with 2.1.
Oh, okay.
You got these 2 lines in there. It says the number 1.1 is the long-term average.
I just don't know where that is so I can see it. I'm having a hard time finding
These
that.
are my notes. So
That's okay.
I didn't
Hang
write
on.
it out.
Might be a trick question.
I guess that's what I'm looking for is where that is. Is it one of these guys?
No, it's not in the homework.
It's not in the homework. I wish I... Look for it. If you could find it in the text, Robert, wherever you have your book there in front of you-ish. I mean,
Yeah, I can put it up.
if you could, that'd be great. Because it sounds like what you did was, you found the average of this distribution, yeah? That was on page...
Yeah, and that's what it is. I just wanted to know why the long term was different.
I'd love to see where that's referenced in the text so I can look at it again, if that's okay.
Yeah.
I'm just not seeing that anywhere. Because now it shifts down to a different, you know, what's this down here? Men's soccer team. Wait a minute, time out. We might be here.
There it is. We say mu equals 1.1. Oh, maybe it got pasted in the wrong place.
2.1? Oh, maybe it's somewhere else as 1.1 as a typo.
Oh, okay.
I'm just not seeing 1.1. Oh!
That's for the problem.
That's the previous problem!
Okay, that's why.
That's up here. That's the men's soccer team problem.
Okay,
I
that's
feel
right.
better now.
So mu is the same thing as the expected value.
And exactly, that's why if you look on your homework sheet, I made a reference to some texts we'll call the average, the expected value, which I like that term. It's what you would expect to happen if you did the experiment. So in other words, if you went into a household with a newborn, you would expect 2.1 wake-ups on average every night. It's like I'm never having kids. So you'd expect 2 wake-ups on average, and that's what the average is. It doesn't mean you're going to get it every time. It's what you expect to get is the center, is the average. Now we've learned in this class, can you always trust the average? Sometimes the average can be highly skewed, pulled different directions. Sometimes you have bimodal distributions, and the average is misleading in that way. But that is what the average of the distribution is in this case, and that's why it's expected. So much better, Rhoda. So much better.
Yeah, that's just it.
Good, good. What I should do, thank you for telling me that, I should go in there and maybe make the gap between that bit and that bit more pronounced, maybe.
Yeah.
That's the beauty of open source. I can actually get there and edit the things. So.
Well, those are confusing. The P of capital X.
Ooh, here's the deal too, and Skylar brings up a good point. Like this right here,
Yeah.
this column versus this column, or this column here. It's just lingo. The way your authors write this, they put the chance of this equaling that. In class, I did that verbally. So I just call this the P of X column, and I assume that you made the connection. That means that X is equal to the value back here, and they're writing it in algebra. So that's just how they choose. So let me write both those things down to myself. And I can make those fixes in the text. I mean, next time I won't be able to do it between now and tomorrow. So make P of X equal X, just P of X. And also on page, what page this is? 162, spacing. Thank you guys. This is the kind of beautiful thing about open source that, I mean, adding the videos, creating extra problems, and then also hearing about this and making it better. I appreciate the input. Well, we're going to make it better. Hattie, go!
E2 on the probability distribution.
Let's do it. Let's do it. Let's go find it. Probability distribution E2. Refer back to Chuck discussion from class.
So my question is, other than guess and check, is there a way to adjust the ANSI to make your game statistics?
I think we can do that. I think we can do that. Let's bump this up. I'm going to need some help from you guys, though, because I need those probabilities from, because I run it in both classes now, and both classes got slightly different results. So let's mute this. Everybody follow the question? Oh, you can't see that now. We're going to look at Chuck again, like we played in class with the, well, we used Excel to generate some value scores. And we adjusted the payout up here, no problem. Down here, Hattie's question is, now I'm going to play casino boss, and I'm going to see how much I should charge to play this game to break even. Make sure you're understanding the word statistically, or the phrase statistically fair. What does statistically fair mean? And why is it Vegas statistically fair?
Because the payout should equal what is being received back.
On average, yes, which means the average of the distribution is going to be equal to what? I think I said that up here.
Whatever your answer is.
Yes, statistically fair just means it ends up being 0. It's not positive, it's not negative. If it's negative, that means you as the player are losing money. If it's positive, that means you on the player, as the player, are gaining money, as you saw. Wasn't that awesome, the New York lottery? The very last problem there, those kids paid attention to the payouts and they realized, holy crap. Every time I spend $1, I get $1.20 back, essentially, was what was happening. So remember the joke I said in class when you play Chuck? You want to just, instead of playing the game, just walk up, hand them $1 and ask for 46 cents change and walk away. In that New York lottery example, it was like walk up, put your hand out, and demand 19 cents. Because that's on average what's going to happen, right? You see what I'm getting at there? That's the difference between a game that's against you and for you. Fair just means it's not against or for either party. It averages out to 0 washes. Beautiful. So here's what I need. I need your help to get me started again on the actual distribution, because this is the part I don't remember. I remember that we have a number of 5s, and it was 0, 1, 2, or 3. We were betting on 5s, I remember correctly, that day. And then, let's slide over here so we can see this better. And then we had the payouts. We're going to change this column. What I'm going to call this payout, we're going to call this X. The payouts for us were -1, 0, 1, and 9. Because it was either lose your ante, 1 for 1, 2 for 1, or 10 for 1. But you have to take the dollar out each time because you're paying to play the game. Here's where I need your guys' help. What's the chance of each of those? So, for example, what was the...
-1.
What was the probability of not getting any of the 5s?
0.5782.
Thank you so much, Nat. 0.5782.
0.3468.
3468, beautiful.
1.0094.
0.0094, like that.
Yes.
0.0694.
069. That makes more sense. It's closer to 7%.
Yeah.
And then this guy was very small, yes?
Yes.
Couple zeros and then a
5.9.
5.9. Thank you so much. Does that sum to 100%? We didn't even check that. It doesn't quite. It's off by a smidge. If you actually add these four decimals up, it's off by a smidge. That's okay. It's rounding error in Excel. So the sum of that bad boy is essentially 100%. It's 100% enough. If you remember when we actually ran this average in class, it came up to be, it called it 1. It was close enough to 1 to be 1. Okay. Now, what I wanted you to do in E2, well, in E1, let's look at E1 real quick. In E1, I asked you just to change the payout for a roll of 3 5s. So I wanted you to leave all these guys exactly the same, but change this number so that the average ends up being 0. Now, you guys that tried E1, what did the payout have to be for 3 5s until the average averaged 0? I don't know if I gave you the answer for this one down there. I think I did. I didn't. What did I put? What do you say? That reminds me. Make a video for this one.
Instructor or something.
Oh, you know why I can't? I can't, obviously. I can't because I didn't have the probabilities. Each class's probabilities are different. I just realized that. I can't
help you.
Right, I can't help you because for the same reason I had to ask you guys what these 4 numbers were. We had those numbers gotten in class. Okay, so what you'd have to do essentially is change that to X. And then create an equation based off of that. Let's do E1 and E2. If it's okay, Hattie, can we over answer? Let's do them both. Okay. And I think this will actually help us answer E2 by doing E1 first. So let's do E1. We're going to leave these payouts exactly the same, except for when you hit big. We're going to call that, I'm going to call it question mark actually, because we're using X for something else. I think it might be confusing if I have 2 X's up there. And you got to realize something. We're going to solve this for the question mark, but we're going to have to essentially add a dollar back onto that because we paid the dollar to play, if that makes sense. We'll keep that in the back of our minds. Good, but rather than make the algebra more complete, we'll just put it on the end. Now, in class, when I asked you to find the average of this distribution, you simply went 1 var stats L, 1 L2, and then called it a day. You can't do that here because the TI will not let you put a variable in for a data point. So what you have to do is essentially do this manually, old school, the way we did last week, which is create the next column and treat it like a weighted average. X times the P of X. Just like we did back in the day with your GPA, just like we did back in the day with the keys, just like we did back in the day with many, many examples. We did it manually a couple times on Thursday as well because I kept saying, I'm not going to usually ask you to do this, however, I want you to see what's unfolding in the components of the problem. So all you got to do is add those things together, or multiply them first. -1 times that gives us negative 57.82 cents. Fair enough so far? Next one cancels out, that's $0. This is very little money, positive 0.694, so about 7 cents. And these are numbers we saw on Thursday. We said, you know, that payout only results in an average of 7 cents over time. You paid $1, but that's giving you back 7 cents. You're like, ooh, okay, but it's only giving me 7 cents back on average. What about the 58 cents that I lost? Is that being undone by this? No, only a little bit. Now here's the question mark. What is this going to be? Well, I don't know. It's a question mark times that probability. So I'm going to put the question mark in green. It's okay with you guys, so it stands out. It's question mark times that probability of 0.0059, and that's a dollar amount. That is a dollar amount. It is. Our job is to figure out what the question mark has to be to do something in particular. Now, believe it or not, this is related directly back to a question you did weeks and weeks ago. You probably don't remember it. I'm trying to flush it out of your mind with enough caffeinated beverages. I asked you, if a student has a certain GPA up to a point and wants to arrive at this GPA, what is he going to have to earn in a given term to get to that GPA? You might remember that from weeks and weeks ago. It's the same problem, essentially, except you have to kind of see how the component pieces line up. So, what are we going to do with these numbers, friends? Yes. Why? I love that. Why? Is that you, Skylar? Why are we going to add them? How did you know that? That's perfect.
I just did it because that was what you did in the homework. So.
Well, that's what we did in class. That's what an average is. It's the sum of this divided by the sum of this. It's a weighted average. But we decided in class we don't have to divide by the sum of this, because what is the sum of this? 1. There's no need. So the average we can just do by summing this column. Thank you. All we've got to do is add that column up, and that's going to be the average. That's going to be the average. So add those pieces together. So you end up with negative. Can I drop the dollar sign? Is that okay if we understand it? It's still dollars. If I take the dollar sign away, it might just get in the way. Negative 0.5782 plus 0, that goes away, plus 0.0694 plus that interesting thing down there with the question mark attached to it, yes? 0059 times the question mark. Say that again.
Divide by 4, not X.
Divide by 4.
Or
Oh, hold that thought, Kate. Let's come back to that if you don't mind. I'm going to make life a little bit easier for us right now if it's okay. I'm going to combine these two numbers together to make one less term. Is that okay if I do that? See if I can do it right. Let's quit doubtful. 8. Carry the 1, is that an 8? Check my math on this, friends. 5088. Did I get that right? Holy crap. It's a miracle. 0059 question mark. Now, I can't combine these two because that one has a variable attached to it, the factor of question mark. So I got this plus, it's linear at this point. It's y equals mx plus b. And mx plus b. That doesn't scare you. But we can't combine it anymore. Now the problem with that is, we can't do anything with that. We know that's the average. That is now the average. So I'm going to slide the camera over that side, because I think we might be missing the forest for the trees here. We now know that the average winnings of this game can be expressed as that number, negative 0.5088 plus the other term times the question mark. Let me ask you a question. How many variables are in that equation?
1.
2.
I heard a couple ones, and then a pause, and then I heard a bunch of 2. Aren't there 2?
Yeah.
There's the question mark, which is the amount we're paying out for the ante, and the average of the game. There are 2 variables. So we are stuck at this point. We can't do anything with this equation, can we? You can't solve a 2-variable equation for either variable because there are infinitely many solutions to that equation. Heather's like, oh yes, I remember this drivel from my algebra classes. Yes. But don't we know one of those values?
Yeah, because what we're trying to do right now is what happens when the average is 0.
Yes, we're trying to make the game statistically fair. So we want that to be
Zero.
0. We want that to be 0. That's the whole point. We're playing action. We're a pit boss. We're trying to say how much should we charge for this game, A. That's actually E2. How much do we pay out for the big roll to make the game fair, because we're going to pay out less than that, which makes us make money. Please, Jenny.
Right here, would you be able to make it, say, -1?
Yes! That's the whole point. With this equation, you've got great power. You can make this be anything you want it to be. -1, -2, -12 cents. What was your average in class? What was our average winnings? Was it -46? Is that correct? I'm remembering that number for some reason.
46 or 47.
46 or 47, somewhere in there, right? You can make it, that's what it is right now with a payout of 10 to 1. Make it 20 to 1, make it 30 to 1, see how it changes. But here's the break-even point for the casino. Make it 0 and see what it comes up. Thank you for that question, it was perfect. Oh, I hear a over there. That's nice. Now, from an algebra state of mind, this is an amazing problem because of the number of zeros in front of this. That makes me exceptionally... This is just a linear equation now, yeah? I told you every once in a while in this class I'd bust you an equation out on you. I told you every once in a while. Here's one of them. Can we solve this for question mark? Yes. Don't overthink it. Just move that over and divide by that, and you're done. So, the amount that you should profit from rolling 3 5s is going to be equal to this, positive now, 5088, divided by that. Before we go anywhere, make sure you guys are believing, understanding how everything's positive now, just by moving stuff around. Little teeny bit of algebra. It is a useful tool from time to time, I promise. I know I slam algebra classes a lot. Algebra's wonderful. I just think we do too much of it. Wait, yours. I agree, Robert. I agree. But it comes in handy here. So what's question mark equal to?
86.
86 bucks? About 86? Is that the nearest dollar?
86.24.
We'll call it, that's totally fine. We'll call it 86 just to make it nice and easy. Now realize that's in dollars. I did drop units as we went along. But the unit that we're talking about here has to be dollars at the end of the day. It has to be dollars by the end of the day. So those are the probabilities. Okay. Now remember, that's how much we have to profit from the game, but we have to pay $1 in. So technically speaking, you'd have to pay someone 87 after betting $1. So 87 to 1 payouts would get the game to an average of 0. They're giving you 10 to 1 payouts. Why would a casino boss want to know this number? Why would a casino... Say that again?
They want to make money.
They want to make money.
Profit margin.
They got their profit margin now. They know as long as their payout for that roll of 3 is nowhere near 86, they're making money. But here's kind of an interesting take on that. They are paying 10 to 1 by chuckle odds, correct? So every once in a while, what can they do? Guess what?
Triple day.
Now it's triple day. Now we're paying 30 to 1 odds, which means you clear $29 every time you bet $1.
They're still making money, doesn't matter.
They're still making money, just not as much as they were at 10 to 1. But they're definitely not losing money because they're not paying back anywhere near close to this $86. You see why we need to know that? And I'm not just talking about pit bosses, I'm talking about insurance companies for the same reason. How much do we have to do to cover our costs, but still have a fair payout to our customers? It's all the same problem. It really is. This is how much you have to do in your GPA to get a certain cumulative GPA. It's all the same problem. It's kind of the neat thing about distributions. It's all the same thing, just in different contexts. Is that fair? Is that believable? Good. And what's interesting about this, the reason, and now I understand why I couldn't answer the question for you in E1, this varies wildly depending on the values of the probabilities, especially this one. You guys, this is actually a little bit higher than it should be. It should be below 0.5%. So I see in that payout range up over close to $200. And it's all because of this number right here and how it can vary by even a 10,000th or two. It's amazing. The mathematics is amazing. So, cool? Is that fair? E1 fair? Ish. Getting there. Sorry about the algebra. It does come in handy though sometimes, yes. Now, how do you ask about E1 rule? Guess about E2. But the discussion of E1 will help you understand E2. I promise you this. I promise you this. I'm going to come back over here to help us answer that. But make sure, E1, are we okay with E1? Ask me if something's not clear. Decent? Good. Let me clear some of this out right now. And we'll come back to this. I want to use this distribution again. And I won't go through the entire solution to the problem only because, although you give me, Scott, you give me something to think about though. There's got to be something I can do video-wise with this problem without actually having the numbers. So, big 4, E1, E2, progress. Okay. So, I'm going to move this over a smidge, just so we have that reference. And I'm going to move that payout over too, and also make it, I want to make this the old payout. Negative 1, 0, 1. And I want to make the old payout 10 to 1, so I'm going to keep it at 9. Because I think in E2 I told you, don't change the payout, just change the ante. Gesundheit, Gesundheit, Gesundheit. So in other words, the way Vegas advertises the payouts for these games is a multiple. 1 to 1, 2 to 1, or 10 to 1, based on your bet. So you bet $1 down. And if you roll 3 5s, they pay you 10 times what you bet back. So and then that can be applied to any multiple. If you bet $5 and roll 3 5s, you're going to win back $50. What's clever about that is the average is exactly the same, no matter what you bet, because it's a multiple of what you're betting. But I'm saying we're going to move away from that. What I want you guys to do right now is let's create another column. And this will help us steer toward where we need to get what Hattie's asking. Can we write the payout, including the ante? So, let me see. This might sound kind of cryptic, but it's going to help us answer E2 really, really easily. Negative 1 is negative 1 why?
Because you lost your ante.
Because you paid $1 to play, and what did you win? Nothing.
But you lost your dollar.
But you lost your $1. So you won nothing, but lost your $1. Is that okay? If I write it like that? Negative 1. Why is this 0?
Because you won $1, but
You won $1, but you bet $1 to play, so that canceled it out. That's hence the 1-to-1 ratio of win to loss. You're always losing something by betting to play the game. I mean, that's, the stack of chips goes down when you play.
That's your safest bet though, isn't it?
Hold tight. Go ahead.
That's your safest bet though, isn't it? Just $1? Because chances are you'll break.
When you say safest bet, how are you defining that, Harrison?
Like you're most likely to get your money back?
You're most likely to lose your money.
Oh, no,
That's what this tells us.
Okay.
You're 58% of the time, just give them the $1, walk away.
You're going to lose it, but like that's the one where you have the most chance of like getting it.
Oh, so of the ones where you get money back, that is the most likely. Yes, it's still woefully unlikely compared to everything else, unfortunately, which is why the expectation is negative. Fair enough?
Your safest bet's just not to go lost.
Now here we go. Hang on, I didn't say that. Like Thursday, I didn't say don't go to Vegas. I said make sure you know what you get yourself into. So you're going to leave with lighter pockets than you go in. Why is this 1?
Because you won $2, but you lost your ante.
Why is this 9?
You won $10, but you lost your ante.
Okay, that's why those numbers are what they are. You take the amount that you won, and this is going to stay the same. The winnings are the same. You win nothing, you win 1, you win 2, you win 10. But what you have to do in E2 is not adjust the payouts, but adjust instead the... You have to adjust the ante, exactly. So you're going to keep the same probabilities right here, but add this column instead. I'm going to take this away as well because it's going to change too. And then once you see what the 2 columns are, Hattie, you can knock out the problem pretty straightforwardly. Here are the new payouts. Okay? I'm going to slide them in right next to here. We're going to call this the X column. Yeah, we'll call it the X column because that's what we've been calling it. So this one was 0 minus 1. Now it's going to be 0 minus, I don't know, called a question mark, because that's your new ante. Your question mark is your new ante. This was 1 minus 1. This one's going to be 1 minus the question mark, because it's the same ante. You're betting the same amount of money to play each time, no matter what happens. 2 minus 1 becomes 2 minus question mark, 10 minus question mark. Then proceed exactly the same we did in E1. Here, look at it.
No, that makes
Oh, so okay, good. I thought I heard just like a deep like a deep like exhale, like more algebra. 4 times as many variables. But what's interesting about that is some stuff disappears. What's great about that is, notice how you've got these guys, they'll be multiplied out, they're going to have question marks. Some stuff becomes very, very nice algebraically. And then set that equal to 0. Do, that times that, plus that times that, plus that times that, plus that times that. Set it equal to 0. Solve for the question mark. That's your new ante, the break-even ante. What gets really interesting is when you start messing with the payouts and the ante at the same time. I'll never ask you to do that in this class.
X and Y.
Because you have an X and a Y in there. You've got a two-dimensional table of results at that point.
It's not that hard.
It's not that hard, but when you're just getting used to a single variable distribution, a double variable distribution can look a little bit daunting. This is what's stuff, actuarial exams. I have tutored so many people through actuarial exams, and those 2x2s are what gets them, hangs them up every single time. It's not that it's hard, it's that it's all to look at it first. So there you go ahead. Solve that question mark, boom, you're done. And then what I'd like you to do is when you take a look at that, also compare the result of that ante with the result that we got in class betting on the odds that we did, and see if you can see a connection there. Yeah.
Would this be like a similar to a test question?
An in-class test question? Hell no. Oh, sweet Jesus. Oh, God. It's a great question. But it's actually related almost identically to your last out-of-class exam question. I would never put this on an in-class exam. No. There's too much going on. Oh, God. No. I try to keep the in-class ones very topical, very superficial, very topical. No. They're worth doing, and I'm still kind of wrestling with, maybe instead of doing quizzes, I should have you guys like turn in solutions to these instead of quizzes, like that kind of thing. Because I like, these questions are great. They're wonderful, and they're how they apply to our lives. But I would never, in a time situation, I mean, I don't want people vomiting in here. What you learning in here? Kate?
Kind of off of that. So then on the test, are we going to be doing, I'm just trying to get a grip, are we going to be doing ones like on the quiz, the insurance one, where you're giving probabilities? Are we going to be, what is?
Very, very simple on the in-class. You'll be given a distribution. Maybe, one thing I like doing, just to make sure you understand what a distribution looks like, is give you a distribution, not like this, but like one that we had in class where you've got, you know what, the hell, let's pull one out of the book here, rather than mess with this. Could one of you guys slide the camera back so it's pointed towards the screen? Unless it already is, it might already be.
We could just do the one for the test if you want.
I don't have it made. That's the thing. I would totally do that, except it's not done yet.
So why don't you pull one from the book?
Here.
And then
Well, I'm going to show you an example.
put it on the test.
I want to show you. Because the ones in the book were a smidge dated. There's a good answer for that. It's so easy for me to just go to your textbook, grab a distribution, throw it on your exam. I'd much rather go into the current news world and extract something from that. But as far as a mathematical example of what you can expect from this, I can give you that distribution, but leave that one out. That probability out right there. Say number 1, find what that should be. Number 2, find the average of the distribution. Straightforward, yeah?
Yes.
Because you can totally figure out what that has to be.
You just,
Because they have to sum to 1, whatever's left to get you to there. Boom, there's that. And then just find the average of the distribution. Straightforward, straight ahead. The out of class, you delve more deeply into what the distributions are when there's no time commitment. So it's really straight, Jay, does that answer your question? Really straightforward. I mean, almost purely mathematical treatment of the statistics, where the out of class is, why did you do that? What do you think about this? I save those questions for the out of class for the most part. For the in class, it's more mathematical. Is that fair? I mean, that doesn't fair. Hopefully it seems fair. Does it make sense?
Yes.
Good.
Is it statistically fair?
I don't know. I have to find its average. I could ask all your opinions, 0, 0, -1, or +1, and average them. But then we had a whole host of problems with that too. Decent? Yes? So that is, think about, let's take 5 now. I'll come back and do a real quick hit or miss as far as what topics are important from the 3 sections. And then we'll get into my chicken flop, which ties back into all this anyway. So we'll have a nice little exam review during the day. Yes.
I give up. I give up. I don't even care. I give up.
What do you got, Bob? That's great. Yeah, let's throw it right up here. That's perfect.
Yeah.
Thank you. Sorry about that.
You're in tomorrow, 12:30.
12:30, sir.
Yes.
Stop by, see me. Be good talk to you. Please, ask away. No, go ahead.
Okay, so.
Yeah, and we're going to go over this, but go ahead and ask me questions now. Yes. Yeah.
So that is where you.
Don't even worry the equation.
Okay.
Just graph the modify box plot.
But you guys help it.
Yeah.
No, I thought
I want you to know, I want you to have to keep less in your head.
Okay, so this.
Yes, that's it, that's the stat, yes.
So the number
And it's
that,
not like measurement.
that's.
Can I put your mind to go a little more easy? Use your TI to graph the
So
modified
it's easier
cost
to put on that.
and see if any outliers pop out. If they show as,
Yeah,
I think there's some beat.
why do you say that to you?
well, because that looks like magic otherwise. In class, I
Oh my
thought
God,
those
oh my God, I figured it out.
because
So
I
you can
always
understand.
otherwise, it's okay, there's a box out there, but why is it out there? In fact, I wanted to show you what the TI is actually doing in its brain. Much the same way that we use one more stats all the time.
Yeah,
But from the beginning, I kind of make you calculate it because I want you to use it. But I want you to understand what it's doing. That makes sense? Now, the two standard deviation thing, that's the bell curve way too.
Oh my God.
That you can run both of these bad boys through the variables menu in the TI. So by all means do that.
What's your favorite thing? Either or is just your.
I'm thinking on the exam, it's preference, I'm thinking on the exam to actually tell you guys to do both ways, that way you don't have to worry about worrying about it, just, I'm gonna have to do this, and I'm gonna have to. The explain will happen on the outer class. I'm thinking on the in-class exam, I just say, find me the outliers this way, find the outliers this way, and then just call it a day.
So, but like for the outer class, that is your preference,
Oh!
which one?
That's what I want, on the outer class, I want you to pick correct. You pick which way you did it, and why, and tell me why you did it. Exactly. Cool, makes sense?
One final question.
Yeah, right. Why care about outliers? I don't know, you tell me. Kidding. Relative position? Nope. Okay, good.
Percentile stuff.
So we should do zero.
Technically, yeah. Mhm. Yep.
Just for
Uh-huh.
example, so minimum.
Was 6, which means that was a 0th percentile. Love it.
So anything at below is 0.
Well, 6 is the below. There is no below 6, so 6 is the lowest one.
Okay, so whatever the min is, that is 0.
Yes, exactly, exactly. And that's a good one. I'll probably end up giving you like a block of data,
Yeah.
and I'll put it in order for you. I won't be a bastard about it. I'll put it in numerical order, and say go in there and find the 40th percentile, the 70th percentile. And there's going to be wiggle room around that, as long as you get roughly 40% of the way up and pick a value.
So do figure out, because like LP's
That's not
Yes.
hard.
So what would you do if you had a block of data? Let me grab one here for you, Jason, show you. No, don't overthink it, but I want you to not in let me grab this page real quick. I gotta think about what
Computer
week
lab.
I'm gonna try week 6.
Where you've got like
It's week 7, right?
a bunch of different tries to get it right. So you find yourself kind of like cheating your way through.
Okay, so here's a good one. This is kind of average. Right, but we can actually use
instead of actual like sitting down and figuring it out. So
So we just put this in the calculator.
it's
Well, it's out of order, and that's unfair. I don't want to take class time while you're working on something to make you like source the data. But I'm gonna do it
I felt okay about that, but I'm a little nervous about
columns here. Limited by 6. There we go. So now I gotta do this. Right. You can't have secretary. Totally. You'll have a nice block of data. I'm kind of in the problem. I think I'm going to see my data. That's the show us all data. The number of broken legs, it's actually when you get a year. Say collarbones, broke collarbones. Oh my God, I ever broke. I've only ever broken one. Holy F. Oh, man. Oh, that's what I did mine. I ran into a tree.
You did not write laundry.
Yeah, that was freaking terrible. I'm sorry. I'm sorry. Okay, so here's, so now I'm gonna put it back in order with copy this, paste special transpose.
I think I'm just thinking.
So you'll have something. Oh, got too much stuff.
Did they win or?
Just data.
So that would be.
Special transpose.
Free.
Oh, come on. Oh, I took the cell.
Can I say your food like always smells amazing?
I was just thinking the same thing.
Copy.
I'm sorry.
Okay. We're like pizza one.
There it is. And now these break up pretty nicely, if I remember correctly. Like this.
You always make
Here.
Harrison, it would smell better with meat though. It would smell better with meat.
Here.
I think it's funny, it's like this is like a mall or something, you know, it's called something for that later. Why?
This, we're almost like I said, this is what I don't want you doing in class. I mean, obviously, this is stupid, like, bookkeeping. Beautiful. All that.
Oh my god, I'm so good, I'm just like.
Is this making you nauseous? I'm sorry. Yeah. Well, you wouldn't do all this. I wouldn't do all this. So there you go. There's a block of data. Actually, you know what? If you don't mind, let's use this as an example about everybody. But this is what this is, and you'll see. Exactly. Exactly. And I'll show you Excel's command too, which you're actually going to use on your out of class. So you'll see that as well. Sir.
So I was trying to figure
Good for you. Good. Good. And right, last semester here too. 0 or 1.
these ones though. You do one of those turns into 60, right?
You're going to have to guess some wrong ones. Right? So you got 20 out of the 80, but then you have to start shifting that down by 1 each one. So in other words, you have to, this one's nice because you matched all 4 out of the 4 you picked. But now you're going to have to go 3 and 1, 2 and 2, 1 and 3, and then 0 and 4.
So what I would do is it would be 60.
We'll give you a hint. Hypergeometric. Yes, I will when you